So I've been messing around with procedural cave generation, and I found a couple algorithms that are pretty easy to use but also give some pretty cool results. This isn't really a dungeon style layout like a lot of roguelikes. Instead, it's more of a cave style system or like terrain style generation. So usually when you start looking into terrain generation, you're going to get directed towards cellular automata. If you've ever seen Conway's Game of Life, it's pretty much the exact same as that. You run it for a set number of generations, then you can just modify some properties and give it unique looks. This can be pretty cool, but there's one big problem when using this to generate cave systems, and that's just that the map will not necessarily be continuous. It just means that you're going to have sections of the map that are inaccessible, you can't get to. There's lots of ways to remedy this problem. You can remove inaccessible areas, you can carve out paths between areas to make it continuous. Often though, it can be easier to just generate a continuous system from the start. So I'm going to show a couple algorithms that I've been using that will always generate a continuous map. The first algorithm is diffusion limited aggregation, which gives you this sort of branching snowflake-like structure. This algorithm is probably not going to be great for more linear travel from one end of the map to the other, but can be very good for a more exploratory system. The first step is to manually carve out a starting area somewhere on your map. For this example, I'm just going to put it in the center. The second step is to randomly generate a point on your map and check if that point is on the wall area or on the ground. If the point's on the ground, then you just keep generating points until the point is on the wall. Step 3, once you have your point, you move it 1 unit in a random direction, not diagonal, up, down, left, right. And if it hits the border of your map, then you generate a new point and do the same thing again. But if it hits a section of ground, then the last position of the point should turn into ground as well. So you're carving out a new point. Then you generate a new point, and otherwise you just keep repeating this step, moving it in a new direction until you hit the ground. The next algorithm is one that I sort of stumbled on accidentally while trying to implement diffusion aggregation. I call it modified diffusion, although it probably has a different name. It's actually a lot simpler than the other one. It works in a similar way to diffusion aggregation, but it produces a more cave-like structure. To implement this algorithm, you start the same way with an area carved out somewhere on your map, usually in the center. And again, you randomly generate a point on the map, but this time you want it to be inside the existing ground area instead of on the wall. If it's not in that area, then you generate a new point, same as before. Once you have the point, you move it in a random direction until you get to a wall. You turn the wall tile into a ground tile, then you choose a new direction for the same point, so you don't reset the point after you hit a wall. You continue using the same point until it hits the edge of your map, then you generate a new point and repeat. Essentially, you have a brush that's randomly painting your map for you, and it guarantees that the map's always going to be continuous. So yeah, I just wanted to throw those algorithms out there for people to mess around with. Obviously, diffusion aggregation is a pretty popular one, but I haven't really seen anyone use the modified version. Even though it's pretty simple, it's pretty much just painting a map like you're painting with a paintbrush. But yeah, that's it.